All right, guys. Today we're going to talk about rational exponents. We're going to be able to simplify rational exponents by converting them into radicals. All right, so a formal definition of a rational exponent is an expression with a fraction in the exponent. We can rewrite expressions with rational exponents or fractional exponents as radical expressions, and it helps us to evaluate more easily. The denominator of the fraction in the exponent is the index of your radical, and the numerator is the power of the base inside the radical. And all of that might be what, but here's an example right here, okay? We have x to the a over b, right? X to the a over b. All right, and a is the exponent inside of this radical, and then b is this index or the number that goes in the corner of our radical. All right, so when we have, and I'll give another example, let's say we have b to the m over n, and we want to write this as a radical. In order to write it as a radical, we put our radical there. All right, this is called a radical, so keep that in mind, right? Radical. And our base is the same base in the exponent, b. All right, b. That's our base. All right. Now that we have our base, our exponent is the numerator. All right, so m. And our index is the denominator. This is the index, meaning the number that goes in this here corner. All right, now we're actually used to this radical a little bit more than we think. If I give you this right here, you would say, oh, it's the square root of 4, and it is. But to say it's the square root of 4 means that in this here index is actually a 2. And our exponent, that's actually a 1. So the square root of 4 could actually be written as 4 to the 1 over 2. How about that? So immediately when we see something raised to a 1/2, that means the square root of whatever that base is. All right. And we can go a little bit further, but I won't. All right. We'll save it for later. So we've written out this chart here. All right. We've written out this chart here. All right. Of 1 squared all the way to 10 squared and 1 cubed all the way to 10 cubed. All right. And we know squared just means a number times itself. And then cube just means a number times itself 3 times, right? So just keep this in mind when we're going through the examples and we need to simplify. All right, for our first example, we're asked to simplify the expression. All right, and we're basically being given these rational exponents, like in part A here on the left. We have 27 raised to the 1/3. All right, and what we do here is we need to write it in radical form. That's what it means when it says simplify the expression. In order to simplify it, we want to write it in radical form. Remember that our what goes underneath our radical is 27, right? This numerator is our exponent, right? The denominator is our index, so we have the cube root of 27. All right, the cube root of 27, what it's really asking is what times itself 3 times is going to give us 27. So that's where we want to look right here and look for 27, which is right here. And it appears that 3 cubed gives us 27. So the cube root of 27 is actually 3. We've written it in radical form and we've simplified to give us a response, which is 3. All right. So with 64 raised to the half, we already said that another way of saying anything raised to the half is just to say it's the square root of that base. So here, this could be written as the square root of 64. And that's like, oh, no brainer. But why is it that way? Well, because our index is 2 and our exponent is 1 here, right? And we're asking ourselves, what times itself will give us 64? And so when we look in our squared column here, we're looking for 64, which is right here. So 8 times itself gives us 64. And that's why our result here is 8. All right, we got a little context here. All right, now we're going to go over here to the right side, because sometimes it won't always be a simplifying. We just need to turn it into a radical. So for instance, we have here a to the 1/6. All right, a to the 1/6, we write our radical and our base a. Our exponent is 1 and our index is 6, and we're done with that. For b, we have m to the 1/2. So we have our radical, right? Our base is m. Our exponent is 1, but remember, we really don't have to write it, so I won't. And then our index is 2, but we also don't have to write it. So this is technically just the square root of m, written just like that. All right, now we're going to go to what if the numerator is something other than 1, right? What if the numerator is something other than 1? So we have here 8 to the 2/3, right? 8 to the 2/3. Well, we definitely need a radical, right, to simplify. And our base is 8. Our exponent is going to be, 2. Our index, 3. All right, there are a couple of ways to look at this. Since we have 8 squared right here, we can actually evaluate this. 8 squared is 64. So we could rewrite this to be the cube root of 64. Meaning what times itself 3 times gives us 64. And it looks like that answer is 4. So this is our simplified answer. It's 4. 8 to the 2/3. Who would have thought it was 4, right? All right, but it is. All right. Now, if we have x to the 3/4, there's not going to be any simplifying that to a number. We would just write it as radical with a base of x. Our index would be, you guessed it, 4. And the exponent 3. And we would leave it just like that. So notice when our base is a letter, we just leave it like this. When it's a number, 9 times out of 10, it probably can be simplified to a whole number. All right, if we have 12 to the 2/3, let's see about this. So we write a radical. Our base is 12. Exponent is 2, while our index is 3. You don't want to leave it like that. 12 squared is 144. So, cube root of 144, let's look at our little list here. Don't see 144. So let's see if this can actually be simplified. All right, let's go to our calculator. Hopefully you guys have a calculator too. And let's see. Yep. I wanted to confirm, but if it's not on this list, that means it's not going to give us a whole number, so we're going to leave it like it is. So we're going to leave this as the cube root of 144. That's our simplest form. That's our simplest form. All right, and then if we have y to the 7 halves here, then we just write our radical. Our base is y. Our exponent, 7. And our index is 2, so we just leave it just like this. The square root of y to the 7. There we are. All right. So over here on the right, we'll have a little bit more of a, I guess, it can look complicated because we're given the radical and we have to change it to a rational expression. All right, so we're going to go through this quickly just so that this doesn't last too long. All right, we have the square root of x cubed, right? So if we're turning this into a rational expression, we go ahead and write our base of x. Our exponent we know is 3, and we divide that by our index, which is not given, so that means it's 2. So that's x to the 3 halves. All right, and then we have in part B, the square root of 5y. Now, what does that mean? Well, we write our base, which is 5y, and we're going to raise that to exponent of 1. And the index, because it's not given, we know it's 2. So there it is. That 5y goes together. So that's why we're able to raise it to the 1/2. In part C, we have our base of 3. And even though it's in parentheses raised to the 3, that's okay. It's still our numerator. That's our exponent, 3 on top. And our denominator is the index here, right? That's the denominator, 4. And then we get to a little bit more of a complicated one, right? And that's okay, because all of this is our base. So that's what we write, a cubed, x squared, y, right? All of that is going to be raised to the 1, right? Over our index, which is not given, so that means it's 2. And we actually could take this a step further by using a rule we learned last week and distribute that 1/2 inside to each part of this expression so that it becomes a cubed raised to the 1/2, x squared raised to the 1/2, and y raised to the 1/2. We know by power of a power, 3 times a half is just 3 halves, so this is a to the 3 halves. By power of a power, 2 times a half is just 1. So this is x. And then we leave y to the 1/2. So this would be our simplified version. All right. I want you to try A, B, C, and D.